Let's see if we can't use our precise definition of the limit to prove that the limit of that linear expression as x approaches 4 is indeed equal to 10. Now, everybody, clearly it's a true statement. I'm not asking to evaluate the limit. It's already evaluated. What I'm asking is, can we prove it using our definition? So here I go. I will typically split up the proof into two parts. Part one. Let's find a delta that works. By the way, everyone, keep in mind, here are my expectations of you. So, given an arbitrarily chosen value for epsilon, we will find a positive value for delta such that in absolute values, the deviation between f of x and L is no more than epsilon units whenever. In absolute values, x minus a is less than delta, but we don't care if x is equal to a. This may be a waste of ink. Don't necessarily need to show that, but this is my first example. I put it in. I gotta confess, it isn't the case that here, this is what f of x is. Here is L. So simply rewriting. There is my A. So here's the name of the algebraic game. Trying to find delta. I'd like to relate it to epsilon since epsilon was given. But delta is already an upper bound for this. If I can find some algebraic expression in terms of epsilon that's also an upper bound for this, I can relate that delta to that algebraic expression involving epsilon. So my algebraic game is to massage this inequality in such a way that I isolate this on the left-hand side of that strict inequality. But I think in this example, that's an absolute piece of cake. Combining like terms. Factoring. The absolute value product is a product of two absolute values. Isolating this in my inequality. Now, you see both this delta and that expression involving epsilon are both upper bounds for this expression, and therefore it tells me I'm going to choose delta to be equal to that algebraic expression involving epsilon. Not enough room down here, but I could write let delta be equal to epsilon over 3. And if you look at what I've done, I've actually proven I've actually proven absolutely nothing. This is just my scratch work identifying how the HECK I'm going to choose my delta in terms of epsilon. So now I actually have to prove it's true. So here I go. Oh, I didn't get a clean board. Isn't that too bad? Oh. Now that I've made a decision, I'm going to choose delta to actually prove the limit of that linear expression is indeed equal to 10. Then I have to assume that this is true and prove to you, the reader, that necessarily the absolute value between my f of x and my L is strictly less than epsilon. Now, if I can bridge that gap, I've proven the limit is what it is. Now, you can yell at me saying the steps I'm going to put in here are just duplicate steps I already had in my scratch work. That may be true, but I'm formalizing this argument. So let me bridge that gap. Now, one of the biggest words you will ever find in mathematics is that word right there. I made an assumption that whenever I see this expression, it's strictly less than, whoops, I put a 0. I didn't mean that, did I? My apologies. I meant this, didn't I not? But I made that assumption. And all of a sudden, I see the absolute value of x minus 4. And my assumption says that I will assume it's less than this. Therefore, 3 times it, excuse me, is less than 3 times that. However, I chose delta to be this expression. Bit of cancellation, and look at that. Now, there is a strict inequality here. That means this is strictly less than that, which is exactly what I needed to show. Therefore, indeed, I have shown that the limit of 3x minus 2 as x approaches 4 is indeed equal to 10. Jeepers. Shoot, new notation. Triangle of dots stands for the word therefore. Diagonal slash to the left-hand side of it typically means it's my final therefore, my proof. This is a symbol I typically use as a mental hiccup, telling the reader this is what I wanted to show. Some people use these letters. It's an acronym in Latin for quad erat demonstratum. That's what we wanted to demonstrate. I see this a lot in books. A rectangle, because it's easy to print. Some high school teachers like that, which was what we wanted. But I like the sophistication of that symbol right there. Oh, shoot. Everybody, my example is shoot. It's far too easy. Let's get more sophisticated.